All right, this is the upward projectile simulation. So the purpose of this activity is to explore the motion of a projectile being launched upward in this simulation. So this simulation covers motion, kinematic equations, upward projectiles, and looking at the graph of upward projectiles. So once you click on the link and you pull this up from Physics Classroom, you can see here it shows you exactly how to set this up. So click on trace path, show velocity vector, show acceleration. I want to see the velocity and acceleration vectors. Set the initial velocity at 10 meters per second, right? So we're going to be changing that initial velocity or the speed, right? Right here at speed. There it goes. There it is. 10 meters per second, right? Start the initial velocity at 10. Great, we got that. Set the angle at 90 degrees. So this is going to be launched straight upwards. We did that and set the height at 0. That one's good, right? So now our simulation is set. So you can see here what we're going to be doing is we're just going to be increasing that. We are going to be increasing that initial velocity, and we're going to find the time to peak and the displacement to peak. Now, finding the time to the peak and the displacement, the highest point, that's a little bit tricky, and I'll show you why, right? So what you're going to do is you're going to get something like this. It goes up, it comes back down. Kind of hard to tell. Now, this time interval, that's not the time to peak. That's the total time. So to find the time to peak, all you have to do is just divide this by 2. But that doesn't get us our y displacement. What that means is that's the tallest point, right? The displacement to peak. So let's just reset this. And here's how we do this. What we do is, like, once it goes up, we're going to pause it at about where we think the half point is, right? So there we go, right? So it's 1.7. Then I'm going to use these these arrows up here, right? So here's my y displacement here. So it's at 5.1. I went a little bit over the peak. It's coming back down right now. I can see that from the arrow. So I go back up. Okay, notice now it's at 5.1 meters. Okay, so I go up 5.9. So it's going back down. So you can see here, this is that point, right? So I'm going to pick the tallest point right here. And you can see here it is at 5.1 meters. And the time is 1.07. So I come in here and I get 1.07 seconds. And that y displacement is 5.1 5.1 meters, right? Good. Now I'm going to just scroll down and I'm going to do the last one just so we can see what it looks like. So I'm going to hit reset and I have to, oh, nope, that's the height. That was my fault, right? So I want to increase that speed all the way up to 60, right? So we're just going to launch this straight up, and it's real easy to see those vectors when it launches straight up and comes back down, right? So there we go. It's going up, it's going up, it's going up. I want to pause it just when it's like just at the peak. So it's just about to get to the peak. So I am going to click on this and I'm going to look at the y displacement. 83.37, 56, 67. Okay, so this is at 67 right here, right? So it stays there. So, oh, there it is. 67, 67. So I'm going to put 6.18. So I have 2 of them. I believe it is 6.18. There we go, right? So you can see here, I think I even added a little bit of a fudge factor in there. I think if you put 6.08, that might be correct. Let me just double check, right? There we go. Yeah, it'll work out, right? I did put, just want to make sure, because there are 2 of there that can do that. So now I come in here and find the displacement, 183.67. 183.67, boom, right? So this is about what my graph should look like, and my data points should fall on this line. Now, once we analyze that data, to show you like the shape of the line, is it, you do have horizontal, linear, not linear, but then we're actually graphing 2 of the kinematic equations here, right? So I show you how to do that. To find the equation the line represents, look at the variable that are being represented on the x and the y axis, right? So time to peak, initial velocity, and then there's displacement to peak and initial velocity. The acceleration is constant, and the final velocity is 0 at the peak for all of them. Find the equation that has the 2 constant variables and the variables represented on the x and y, x and y axis. It says any, right? X and y. So just find the equation that has that, and that'll show you which of those equations that these graphs are representing, because we're changing that initial velocity that it's being launched up at. Good. Now, if we scroll down here, now we need to look at the graphs. So position versus time. if I'm looking at this, right, going all the way up, all the way down, that's what it's going to look like, because it starts at the origin, goes up to a peak, comes back down. Now, if I try to find the velocity versus time graph, I'm just graphing the slope of a position versus time graph. So if I graph the slope, well, it's going to start at a very high velocity, right? Because I'm launching it up, and it starts at a very slope, and then it goes to zero. It's going to cross the origin, so it's going up. So I know it's going to be positive velocity, then it's going to be zero, then it's going to be negative. This is going to be the slope of my velocity versus time graph. Notice, well, look, it's getting slower and slower and slower, and then it crosses the zero. Then at the very peak, it's not moving. It's just at rest before coming back down, and the velocity is negative. And the reason why I know it's a straight line like this, because the slope of this velocity versus time graph is my acceleration. Acceleration is going to be that, right? It's just going to be negative. That's the slope of my velocity versus time graph, right? Then just tell me what the shape of the slope is for all the graphs and what they represent, right? And it all has to do with the rise over run. I sort of went over that, right? So the slope of a position versus time graph is the velocity. Slope of a velocity versus time graph is the acceleration. Slope of an acceleration versus time graph, that's just my change in my rate of change of acceleration. How much is my acceleration changing? The acceleration is not changing. So now this part, I've got three different conditions, right? So one, the projectile is moving up at the peak, and then when the projectile is moving back down. So I want you to look at this and look at the graphs and tell me, well, is the position for all three of these, right? Is it positive, negative, or zero, right? Then tell me about the velocity, and then tell me about the acceleration. Now, the last question says, well, when a projectile is being thrown upward, does the acceleration change? I mean, you've already seen that in the graphs. It does not change, but explain why or why not. And the hint is, well, what force is causing the object to fall back down when it's throwing up, right? What slows it back down and then brings it back down? What force? And does that change during the projectile motion of this projectile, right? So once again, this is the upward projectile simulation.